I'll be the instructor for this course. It's gonna be 5 hour course that we're gonna go through how to use Python to do basic data manipulation statistics, as well as creating your own predictive model, which is very exciting. So in this first tutorial, we will talk about data wrangling, pretty much, data manipulation. How do you use Python's basic libraries to manipulate the data and get ready for modeling later that we're going to be doing. So we'll use practical data set to do the learnings of the following topics. So the first one is going to be cleansing the data. So definitely it's very important. A lot of time the data you'll get is not going to be clean, of course. It's very dirty. You have to go in and filter out noise and make the data available for analysis, right? That's going to be analysis ready. And then the next one, we're going to talk about statistics, like simple statistics. How do we take the mean? How do we find out the mean, max, minimum, as well as median, and so forth? How do we plot a basic histogram? How do we have better understanding of the data from statistics perspective? Then the third section is going to be practical examples of data mining. So we're going to be using actual data set to, go over a few Python tricks so that we will be able to have better understanding of data and then manipulate data better. And the last section is data set examples. So there are a lot of places you can get data, but we're going to go over how to get the data set. So right now here you see it's actually Jupyter Notebook. So which I will go over at the end of this lecture, how you can install this and how you can get your Anaconda, how you can get your Jupyter Notebook. But for now, let's say, you have everything set and now we can, get started. Section 1.1, data cleansing. So as you can see, I already typed out a few things, but you pretty much always use these libraries. So a quick way of doing this, once you have Anaconda set up, so you need to actually Conda install every library in here. So pretty much you'll go into terminal. If it's Mac, then you can just click on this terminal and then just waiting. You can actually pretty much put conda install of the individual, like I already have the library, so I don't want to do it, but like you can actually just do conda install of say pandas. And then you will install it. It's gonna say you already have it, but this is how you can actually do this installation using Anaconda for individual libraries. It says solving environment. Don't worry too much about that. So after that, you can actually get some message. But the first thing definitely is Pandas. Pandas library is very, very popular in Python. So it allows you to manipulate data in a data frame format. So pretty much it's pretty close to Excel, right? Think of it as Excel. You can have this like grid format of the data, and yeah, you can see that here is pretty much like it exists, so no need to do anything. So then it's very useful whenever you have a CSV, you have a text, you have any text data or any file that you save locally, you can load it to Pandas data frame and then manipulate your data there. So the second library you can see is Seaborn. So Seaborn is another very popular library that you can use to do pretty charts. So you can plot very like different visualizations and charts using Seaborn, and it's very easy to use, user-friendly. NumPy is another one that's very popular. So it's NumPy. It's not NumPy. It's NumPy. And then I would say I always use NumPy just because it allows you to do this, we call it this concept of broadcasting. So you have a NumPy array and then you can broadcast it so that it will really help the runtime, meaning you can apply a logic to every element in this NumPy array, and then it runs a lot faster, and then it's very easy for you to manipulate the data or the NumPy arrays. So it allows you to pretty much like do data manipulation easily. But here today I'm not going to be using it. I just wanted to have a quick introduction of NumPy, but today we're not going to be using NumPy. And then the last one is matplotlib, pyplot. So this is another very popular library that you can use for visualizations. So as you can see, that it's very easy to like import anything, right? Once you have the Conda installed, like you install everything, you just pretty much do it. Import any libraries that you want, Pandas as PD, and then all these things, and then read out, and then pretty much I always copy and paste this part because always you'll use all these libraries. So and then notice this as, so pretty much I have as Pandas as PD. This is think of it as a shortcut or a nickname of this library, so you don't have to always write out Pandas whenever you're trying to call this library. You don't have to write out the entire name, which you'll give it like, PD dot something, right, as opposed to Pandas dot something. So that's why people always want to use this asterisk like PD, like shortcut alias, sorry, PD, SNS, MP, all these things. Okay, so then last thing is a percentage matplotlib inline. This is just to say that I want to, this is actually a trick in the Jupyter Notebook. I want to show the plots in line, meaning like I want to show the plots in my notebook. I always have these things, so it's best for you to just remember it and then copy paste it pretty much every time you will use these things. So let's say we are going to have some fun. So let's say we have this data set, right? It's saved in CSV. It's called single family home values. This is actually coming from Zillow, right? So it's Zillow, which is like a public, you can actually get this from their website as well. So it's a public data set. So Zillow is an app that you can use to when you try to actually buy a house, you can actually look at the stats of each house and the histories and also the estimated value for each house. And then I actually got this data. Say I'm just gonna go in here. Okay. I have all these. So you can actually, I'm just going to open up the CSV. So I download this CSV from Zillow's website, and then, it has many columns, of course. It's just a CSV file, right? You can actually see, a lot of columns, a lot of rows. I want to just, do something with this data set and then find out maybe there's some useful insights that, I can use for my projects. So say, the way that you can load this, right? I mean, I already typed it out, but like the way that you can load any data, right? Typically in CSV or text data is really just like you always want to assign this to a variable that's called df, but df is equal to PD. Remember, PD is our pandas dot read CSV of this file name, right? So I auto tap that, so like you can actually see whenever you're in the right directory, which in this one, we have this IPython notebook sitting in the same place as this CSV file, right? So whenever you're in the right directory, you can just like auto tap it, right? So that it will auto fill everything for you. So then you can actually say, okay, I'm going to, so remember this like sharp, this thing is actually comment. So you can actually write anything, right? So comment, this is how you can actually write comment. So add things that you want so that you can follow later or someone else can follow you or code later. So now, and then the way that you can actually use this Jupyter Notebook is you can actually delete it from here, right? So you can see this delete button, you can delete this. Or if you want to add more, then you can just like click on plus. And the way that you can run this is really, in Mac, is shift return. So shift return, or you can just click on this thing. You can then click on run. Actually, don't use this. So yeah, like this, we'll actually run it. Run the selected cell, you can actually run this. But I always just do shift and return. So it's a lot easier. And then you can see whenever it's run, there's a number to it. So this will tell you this is the 48th cell run in this notebook. And then you can run it and then just run it. So so now it looks like this data set has been saved as DF. It's called DF. you always want to use this variable called df because it's a data frame. So let's say df.head, which is very, very, very useful. You'll always use it. So df.head will tell you the top 2 rows in this data frame. So you can see all these columns, pretty much same as what we had right before. Not this one, sorry. In our CSV, I closed that, but like in our CSV, we had the same thing. Right, you can actually change this to say 10. I don't want to do just to 10. I can still do 10, right? So this is how you can actually look at it. Just a quick preview, so to speak. And then, okay, so I have all these columns. I have all these, numbers, data. It's great. So at least I have a format that I can, start using, so which is saved in a data frame format. So you can actually, there's another way that you can look at the type of this DF. It's going to say Pandas core frame data frame. So it's a data frame, right? So, all right. So now we have that. And then let's clean this thing a little bit. Okay. So another thing that's very useful, I already wrote here, but it's df.shape, right? So shape is telling you how many, this is the number of rows, this is the number of columns, right? So in this data set, we have 15,000 rows and then 18 columns, a lot of columns, a lot of rows. So it's definitely a big data set. And then the other one that's very useful, I always use, is it's called df.info. So info is another function. Notice the parentheses, right? So whenever you have this parentheses in Python, that means it's a function. It's an innate function. The reason I can use this function is because this function is coming from Pandas, right? It's a Pandas embedded function, innate function. And then because I have saved my data set, my CSV, as a Pandas data frame, I can use all these functions that are embedded in Pandas. So, which is great, right? So, I mean, that's another reason that we want to use Pandas data frame. So we have this info. You can see that it's pretty much a summary of the columns. We have ID, address, city, state, all the way up to estimated value. And then you can see this is a number of values saved in each column or each feature, right? So you can see 1500, 1500, and then there are some missing values. Whenever you see the lower numbers in here, that means the difference, right, of these two will become the missing values for latitude or longitude, right? So we'll talk about how to deal with like missing values later, but just notice that you can look at this through df.info quickly, right? df is our variable that we assign, right? But the type of this is a Pandas data frame. Therefore, we can use all these .shape, .info functions that are, that exist in Pandas. So notice the missing values here, and then there's another missing value, right? It's only one missing value, literally, for year built. And then there are more missing values in here, prior sale date and prior sale amount. So this is how you can quickly look at how many missing values you have, how many, what's the stats for each column. And also notice in here, right? So int 64 object and blah, 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 float. So this is a type. This is telling you the type of this column. So ID is an integer, address is an object, right? Whenever it's object, think of it as a string, right? And then this is, city is a object, and zip code is integer, latitude, longitude is a float, right? And then you have, all these columns. So great. So that's, very useful. And then the other one is, describe, right? And notice that whenever you type it, right, and then you can just autofill it, right? So I type it like up to this, and then if I just click on tab, it's going to autofill it, and then it's going to go like this, right? So I will have the statistics for all the numerical values. Remember, the numerical values in this data frame. So we'll have ID, zip code, and latitude, all these numerical values. And then you can see the count, right? Number that are not null, right? And then mean, right? What's the mean of ID? I mean, it doesn't matter that ID is not, so it doesn't really have any meanings for ID, but perhaps for rooms, it has a lot of meanings, right? The average room is really 6, right? It tells you that it's 6. Average bedroom is 2.7. Bathroom is 2.1. And then standard deviation, right? And mean, right? Like minimum. And then 25 percentile. This is, 25th percentile. And this is median, right? 50th percentile is median. And 75. And then maximum. So it's pretty useful that you can actually look at just, with one function, you can look at all the statistics for each column, right? So that's great. Now then we'll talk about missing values, right? One thing we can do is just fill it with with 0, right? We want to say df is our, again, data frame dot. So there's another function, very convenient function, fill na, right? So you can, again, and then when you type it, if you have more than one matching functions, you can just, it will give you a list and then you can just click on it and then you'll get that. So fill in A, you can actually choose 0 or, literally just like missing, right? This will actually fill all the missing values with this missing string, right? Or I can just say 0. That's a very easy way of doing this. And I can actually assign this to another df, right? Call it df2, right? And then df2, I fill it with 0. And then I can actually see, right, df2 dot info. Let's look at it and see if we have any, right? You can see that it's actually all filled with 0. Therefore, there's no missing values. The count for non-null values for each column is actually now all 15,000. That's great, right? So that's, very convenient. And then, but sometimes you don't want to fill it with 0, right? You want to do something like something that's more intelligent. So say we want to fill it with mean, right? Mean of each column. So this is what you can do. So, I already wrote it down, but it's df dot, right? Same thing, fill in a df dot mean, right? So this will actually fill it, all the NAs with mean, right? So let's call this thing again as df3, right? We're going to assign this to another df that's called df3, and we're going to look at the stats, right? Of, you can do info, and then you see that there is actually prior sales date, just because this is the date and then, it doesn't have the mean, right? You can't really fill it with the mean. But that's okay. So that we can actually talk about how we want to do this to fill this missing value for prior sales day with more intelligence. But for now, just remember that you can actually have different ways of filling this. And then you always want to check that if the missing values are there or are they significant. For this one, I don't think that is so significant except for this prior sale day. That is not very, very significant. If anything, I can just drop anything, right? So there's another way of dealing with missing values to just really drop all of the values. So what if I say, df dot drop, you can see that again, drop NA, right? And then one thing I can do is in place, right? In place is true. We'll just say that I don't have to assign this back to a df. So one way is like I'm dropping all the NAs and I assign this back into our df, meaning I want to overwrite my df. That's one way. Or the other way is I can say drop NA in place, right, is equal to true. So this means I want to overwrite df with, after dropping all the NAs. So if we do this, right, so we then look at df again, right, the same thing, info. You can see that it's all dropped. Therefore, the total counts are now is a lot less than the original number, which is 15,000, right? So there are many ways that you can deal with this. A lot of time it's more arts than science. You have to, if you have a lot of domain knowledge, then you know what to do when you see a missing value. But now you know the basic way of dealing with missing values. So going back to what we're trying to do is making data available for analysis. So I want to then, talk about outliers because, we're talking about missing values. The next thing I want you to know is you need to be careful about outliers as well. So one way of really looking at outliers is you can use Seaborn. Again, SNS is Seaborn library that you can visualize things very quickly, right? So, and then we can just do a box plot. Simple box plot will tell us, right? So this is how you can see, okay, I have some outliers for estimated value. So first of all, how you can call a function, a field from a data frame is you can actually do dot estimate, and then you can of course fill it out, autofill it, right? So this will give you this entire column of estimated value. Remember there was a column that's called estimated value in our original data frame, and then we want to only use this field, right? So this is how we can call this field. Or another way of doing this is like this, right? You can put the square parentheses around it and then do like this. It's either way, right? People use this like interchangeably. So I will highly recommend when you have the columns, when you name your columns, you should be careful. You shouldn't have the like, something like this. This wouldn't do, right? Because you have a space. So therefore, I always put underbar if I want a space, right? So that you can use a dot, you can use this method to call this, to get to this field, as opposed to, something like this, which is more typing. So, and then, other tricks are like, okay, so how would you then want to, what if you want to grab two columns, not just one column, right? From this original data frame, because we know that we have, other columns in this data frame. So we can actually look at, say, year bill, right? So that was another column. We can actually do it this way. So notice that you want to use two parentheses in here, right? So now you can actually see, okay, this is the estimated value and this is year bill. So this is to really understand how you can slice, right? Taking a subset of the original data frame, right? So you can actually, add more things like prior sale, amount, right? And that way you can get more columns. So which is very convenient. So notice that is two, right? The reason for that is you're actually passing a list of column headers into DF to get to this, right? So really practice on like how you can slice the data frame, and then you can always do a dot head in here as well, right? What if you don't want to show everything? You just do it like this. So this will only give you the top two, um, rows. And then, okay, let's go back to like our missing values, right? So now we have something like this, right? We notice that there's like, some outliers in here and here and here, right? Notice that the unit is actually e to the power of 7, so it's a really big number, right? So what if we want to, just eliminate some of the outliers? First, this is inspect, and the other is, to eliminate, right? So we can say the rule of thumb typically is like, one is definitely visual inspection. You're like, okay, so these are the outliers, then I can get rid of them. Or you want to say whenever it's above, 75th percentile, or below 25th percentile, right? You can actually have the hard cutoff to really get rid of these outliers. So it's a lot of time um, there's no one rule. You can try out different things, but for now, let's just get rid of these, these few, maybe three, right? Three outliers. How do we do this, right? So we need to again slice our data frame. So again, we're looking at estimated value for each house. So what we can say, whenever this estimated value is greater than or greater than 8 80 800, this is 800,000, whatever is say, so to the power of 7, right? So yeah, so whenever it's over 800,000, then we want to treat it as an outlier. Therefore, we only want to include the ones that are less than 800,000, right? So if we do this, so notice that you'll get this thing, right? Another data frame, right? So we can actually, again, use shape, right? To know how many are there. It's a lot less than what we had before. So df.shape is really, what's this? So right now, because we dropped all the missing values, is about, 11,000. And now, it came down to 9,000. So we are actually getting rid of some of the rows because we want to get rid of the outliers. So say this is the way that we want to slice our data frame, right? So notice that the condition that you put in here, right? This is a condition which will tell you it's going to be a Boolean value. So you're going to get false, 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 true, 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 false, right? So for every row, you are going to get this Boolean value. And then when you pass this condition back into your original df using the square parentheses, you're only going to be including the ones with false, with true value, right? Hold on a second. Okay, my bad. So I got rid of one of the zeros. So yeah, so this will become, a new df without the outliers with, more than 800,000. We can actually change this up, make it more strict. I bet this one is going to be very close to, yeah. So, or we can just have a hard cutoff and say whenever it's over 1 million, right? So this is 1 million, then we don't want to include it. We'll treat it as an outlier. So this is how we can only grab the ones with less than 1 million value, right? So we can say, call this another df, right? We can assign this back to our df. Now this new df doesn't have the outliers. Everything is over, less than 1 million. And then we can actually do this thing again, right? The box plot, and you can see that, yeah, it looks right. You're not skewed. This box plot doesn't look so skewed like before, right? It doesn't, it's not so skewed due to all these outliers. It looks, somewhat, a better shape. And then the thing you can look at is very convenient is the histogram. So what if we want to know the histogram of this, right? So df.estimate, that's how you can actually get to this field. Very easily is just .hist, right? This is how you can plot a histogram. See how easy that is, right? So after getting rid of the outliers, you can see the sharp cutoff in here, right? Because we got rid of all of the houses that are, worth more than 1 million. So you can see the hard cutoff here. And then, the shape somewhat looks normal. I would say kind of normal. And then, the peak is around, I will say 450,000 or 500, thousand. So half a mil, which is, about right. So then, so this is really to tell you how to filter out the noise and slice df, right? So we've learned how to filter out the noise, such as getting rid of, the outliers. That way that we do get rid of outliers is we can actually call this the field that we want to use and then put a condition, right? Less than, say, a number, and then passing that back to our df, right? This is how we can get rid of the noise. And then this is how we can slice or take the subset of the df, right? What if you have like two conditions, right? You have to put parentheses around it and then just connect it with, like this. So you're going to have condition 1, condition 2, and then condition 3, right? So we can try it. So let's say df.year built, right? So what if we want to only look at the year built that's after 2016, say. And then the third condition will be df dot zip code. We don't have the zip code. Oh, actually, one more thing. So let's see if I want to get to the unique value of zip code, right? So I can actually just call this field, which is a zip code, df.zip code, and you can see that you can get all these zip codes. And then what if I want to do unique, right? It's very convenient. You'll get a unique, right, set of or list of zip codes. So there, because I wouldn't know what's there, right, and what to like use. So I can just say, okay, in here, zip code is equal to 22, right? So something like that, right? So then this will give me, it doesn't look like it has it. So 9. Okay, it doesn't have this one. Okay, maybe the data set is old. 0 and then 209. Okay, so now we have something, right? So this is how you can have multiple conditions and use many conditions to slice your DF, right? So it's very convenient. You can see that it's all pretty much after, it's built after 2013, year built, right? It's after 2013, and then zip code is all just 1, right? 80209. And then, of course, the SN value is less than 1 million, right? This is a way of like really slicing DF using multiple conditions. What if I have OR, right? And then I can actually use the pipe, which is like telling me OR, but now I have to use one more set of parentheses to say this or that and zip code is equal to this, right? So this is how you can build out the logic of different conditions. Okay, so great. So, and let's move on to our next section, which is about statistics. So we talk about, using df.describe, really df.info to look at the statistics, but what else can we do, right? And we'll talk about even the histogram as well. So histogram now looks like that because we got rid of a bunch of outliers. And then box plot definitely is very useful. So what if we want to look at the correlations or the relationships of different columns, right? So one way of doing this is using Seaborn's pair plot, which is very, very handy. You need to know this. And then what we can do is, maybe I'll just type it out in here, SNS dot pair plot, and then what you're passing inside is really just a DF, slice version of DF, or you can pass the entire DF, but I will, because we have so many columns, so I will just select a few, right? You can actually say, I want these 2 columns, right? Remember, you need to do the double square parentheses, right? When you want to only grab, say, few columns from the DF. So then I can actually add more if I want, like year built, right? So this will give me the pair plot. It's going to take some time to run. Okay, so now this is a pair plot. It looks somewhat not so great because it's all like big cluster. So what if I do something like this, right? So like you can see that visualization takes a lot of iterations. You want to try out different things, right? One cool thing about pair plot is you can add this thing that's called hue, which I use a lot. So this is just this will allow you to have the color overlay. So let's try this, right? So I said I want, the hue as zip code. Then you can pretty much see, okay, so with zip code being pink, that's like 80209. You will have different color overlay, right? So, and then you have all these type of, we did the zip code dot unique to tell you this is a unique zip codes, and you have different color overlay. And then from here, what I can see is the first thing is diagonal, right? So the diagonal ones are actually to itself. So pretty much this is to say last sale amount versus last sale amount, right? All of them are pretty much like in here, or just because we didn't get rid of the outliers. So this is pretty much to tell you the histogram, right, of that. So you can see that this estimate value versus estimate value is the histogram on its own, and that it's pretty normal, right? And then in here, this is to tell you most of the houses that we're getting in this data set are coming from this one zip code, right? This is the biggest zip code. And then what happened to the relationships, right? So what if we want to say this is the estimated value, right? And then based on different zip code, right, you can actually see the estimated value. Definitely this one, because most of the houses are coming from this zip code, you can see it has like wide range of estimated values. And then what if I want to look at the estimated value versus last sale amount, right? So now this plot Y is actually last sale amount, and then X is our, so yeah, sometimes like Seaborn takes up a lot of space, so it will just slows down the computer. But the Y is last sale amount, and then X is estimated value. So you can actually see, okay, there's some relationship because of the outliers is not looking so good. So you know what? I will go ahead and I remove the outliers for previous last sale amount. A last sale amount should be less than, again, or equal to 1 million. So is this the right number? I think I added one more. Okay, so, and then I want to do the same thing as we did before, assign it back to DF. And now I'm going to look at this pair plot again, right? Because the outliers, if you have the outliers, a lot of time it will skew the plot. So now it looks a lot better because we got rid of a lot of outlier. Therefore, you can see the histogram, right? For last sale amount, it looks like somewhat normal. This is a histogram for last sale amount. This is a histogram for estimate value, and this is pretty much the plots or the histogram for zip code, right? But because zip code is not a continuous variable, therefore you'll see the bars like this. Now let's look at, the relationship between estimated value and then last sale amount. It looks somewhat linear, right? With, a huge blob almost, but it's a linear, I would say it's a linear relationship. That means the higher the last sale amount is, the higher the current or the estimated value should be, which kind of makes sense, right? And then the opposite of that is really like, it's this, right? So if we just swap X and Y, so this is the plot. So X now is last sale amount, and then Y is estimated value. So what we're saying is that the higher the last sale amount is, the higher, right, the estimated value is, which, makes sense. And then you can see with the color overlay, a lot of time you can actually draw a lot of interesting conclusions. You can see, okay, the outliers here, like, which means the last sale amount is high, but then the estimated value is not so high. It's coming from green, like somewhat like this, like 80204. That means this zip code is not, is one of the outliers. It's not, just because last sale amount is high doesn't mean that the estimate value is high. Maybe something happened to this area. It could be the crime rate. It could be any other factors that are not really, it's contributing to like the current estimated value. So yeah, there's so many things you can do. And then I added one more thing. It's like Seaborn has like many fancy models, plots you can do. So you can do SNS.strip plot. So now I can see, by zip code, X is my zip code, df.zip code. This is how you can get access or get the field, right, which is zip code from this df, and Y is your estimated value. So this is actually very convenient in a way that you can see by zip code what is the estimated value and then its distribution, right? This is like almost like the scatter plot for every zip code, right? And then you can see, okay, so this one has like, some outliers here, but pretty much, all of them are here, right? And then this one won't have one data point, so it doesn't count. These few, it's like very minor. So it's very convenient. And the other one I will say is CNS, the Wrangling plot is very popular as well. You can do almost the same thing. So X is equal to df dot zip code, and then Y is equal to df dot estimated, right, value. So you can actually look at the Wrangling plot, which might take some time, but it looks like a Wrangling. But these two, only have one data point, so you can't really look at the distribution. So Other ones you can actually see, yeah, this one actually has pretty high blue, right? And then pink. These two zip codes have, they tend to have higher estimated value overall. So these could be like more like expensive areas like downtown or very, good areas with good schools. And that's why, the value of the house is actually increasing or higher than other zip codes. But I mean, these are all the things that you can do to look at the statistics, so to really compare the differences and then draw useful insights from your data set. And then, I said something like in here. So I said something like, okay, so let's say you have, so if we just do a quick, info again, right? So df.info, you can actually see all these columns, but the date is not in a date format, right? It's only just a subject format, object format. So we don't want to keep date as a string. We want to convert it to a datetime format, right? Pandas datetime format. So there's a very convenient thing that you can do. So just do PD. So PD is our pandas library. So PD dot to, right, datetime. And then you can pass this column, which is called prior sale date, right? If you do this, this will give you the actual daytime, right? So, and then what I can do is, we haven't talked about this before, but we can actually assign this new thing back to the same field name. So this is how you can assign values into a column, right? You can actually do this with the new column too, right? So what if I want to create df dot, new column, right? So I can just call this just one, right? So this is going to be a dummy column. And then when you actually do that, you can actually then look at df dot head. Notice that there is this new column, right? So like one. But then I can drop it later, but this is how you can do the column assignment. So now, because I already have this column, I'm just going to overwrite it with this datetime format. So I can do that. And then I can just do that for, there is another column that's actually should be in a datetime format, which last sale date. Okay, so now I have all this. And then I can do df.info again. Oh, so okay, so info again. Now you can actually see, okay, so I have last sale date, which is date time, right? It's changed from before. Now the type is for prior sale date is date time again. So that's great. Then now you can do a lot of fancy things. So what if I want to say date.dt, right? This is an innate function. And then you can actually say date means datetime dot year. If I just do this, it will give me the year for last sale day. If I do months, right, it will do the same thing, months or day, right? There's so many things you can do. And then I think there's a weekday as well, weekday, right? Weekday, right? You can do weekday name, as you can see, which will give you Thursday, like the name of the day. Or if you want to just have a numerical value assigned as a weekday, I believe 0 is Sunday. You can actually do it this way too. So what if I want to create a new feature, a new column that's called weekday of last sale date. All right, so you can actually assign this back to our DF, and then the column name is called weekday last sale date. And then now we can look at DF again, right? You can see head. I use head all the time to check if the new column is added or not. So you can see it's added in here, right? So which is like very, very convenient. You can do a bunch of other things like, what if I want to do year, right? And then I can say in year, right? So what if I want to then do this same thing for prior sale date? And then this one is going to be prior sale date, right? So prior sale date, I think it's like last sale date is the last time the transaction happens, and then prior sale date is actually when the sales prior to this last sale happened. So that's why you can actually look at this one, say, okay, so yeah, okay, cool. So then we are going to look at head. Okay, so we have, all these added columns. So now we can actually, like, in a way, create another column that's called, time between or year between last two sales, right? Because, something like this. So we're going to use these two columns, year prior sale date and year last sale date, to do this, right? So literally it's just one line of code. So you can do df dot last sale date, sale year, no, it's year, and then last sale year minus df dot year, and then prior, right? So this will tell you the difference, right? How long did it take for the last after the prior sales date, and how long did it take for the last sale date to happen? And in the unit is year. So you can actually look at this again and see, okay, is it added? Is it calculating it right? So, okay, so I have this 3 in year. So yeah, 2009, 2004. So yes, the difference is 5, right? So prior sale date year is actually 2004. And then last sale date and the year of that is actually 2009, so the difference is 5, and then this happens in the same year, so it's 0. So yeah, you can actually, do a lot of these things by changing, a string or object to Pandas to Datetime, right? So that's why I converted to Datetimes, because I wanted to use all these functions, like convert to year, weekday, and so forth. So great. So now let's look at the actual correlation, right? Which is like made very easy. It's like df.core. That's it. So core is a function, therefore you'll have to have the parentheses. So df.core will tell you all the correlations of the numerical fields. Like numerical fields can like only numerical fields can have correlations, right? So you can actually see what is the correlation of, because what I'm interested in is really, it's a huge matrix, but what I'm interested in is really just the estimated value, right? So this is what I'm interested in. You can actually see, go down as 1 to 1 is because you have estimated value to itself, therefore the correlation is always going to be 1. But what is the highest one, right? Just eyeballing this, I see 77. Right? What is that? I'm going here. It's going to be, last sale amount, obviously, right? That's what we saw in the pair plot as well. But what can we do to like make this more like user friendly? Because it's kind of hard to like scroll up and down, left, right. So what we can do is just pretty much, this is actually a data frame on its own. We can actually take the type of this, right? Let's say type. Okay, so it's a Pandas data frame. So Pandas data frame has another like very useful function that you can use to slice it. So you can actually do location, right? So location or iloc is going to be the index location, will allow you to do something like this, right? So this, you can actually put the rows that you want, the rows, and then this will be the columns you want, right? And then you're going to separate them with this comma. But then the rows here that we want is really the estimated value, right? And then the columns here is pretty much everything. When you put everything, it's like this, it's a column. So it's more visual. Now I can look at, different values only for estimated value, right? Because that's what I'm interested in. So to its own, it's always 1, but then, okay, new column, it doesn't really matter because I just add it. So obviously the highest one is the prior sale amount still, right? It's in here, right? So what if I want to sort it, right? Sort, I guess you can sort values, and then you can actually say something like this, right? So when you sort it, and these two they don't really count, so you can actually say the highest one is this, but I want the highest one to be, to come on the top. So you can actually say ascending, right? Ascending is equal to false. Hope it works. Yeah, it works. So you can actually say, okay, I have all these columns, and then the highest one is indeed this one, right? And then later, when we get into modeling, I'm gonna actually take, say, the top few features or columns because they have the highest correlations. In this case, it's gonna be last sale amount, square footage, bathrooms, rooms, right, and prior sale amount, right? So I mean, it is intuitive, right? Like these are pretty much important features, like when it comes to the value of a house. Yeah, so these are the things that you can do in terms of statistics, including visualizations, including looking at the different, stats, right? And then definitely the correlation function is very, very important. So now let's, do some practical examples of data mining, right? Let's use the same data set, but I want you to know that there's another very convenient function, which is called group by, right? Prior to this, we're like talking about you can use df.describe to look at the mean, the max, or the basic stats. But what if I want to look at the mean of group it by two columns, right? Not just the zip code, but something else, right? So this is where like you want to use this function called group by, right? So what if I said, right? Group it by zip code. I mean, it's already in here, but let's just type it out, right? Zip code, right? So I want to group by this column called zip code, right? DF, it's always this order. You have to remember this. So df dot group by zip code dot estimated value. So this is the column that I want to take the aggregation of, right? So I can just say mean, right? This will tell me, okay, for every zip code, this zip code, I have the mean of estimate value of this and this and this and this, right? So what if I want to then, you can guess like max. It's very easy, right? You can just change it like this, mean. Okay, so now let's say I want to group it by two columns, not just like zip code, but year built, right? Year built, you can actually do it this way, right? So you can see for every zip code, every year built, I have this mean estimated value. I can actually change this mean, right? So, or median, right? It's very convenient. You can actually group it. It's kind of like, that's a pivot table for you. This is great, right? So then we can have many columns, as many columns as we want. But this is actually, if you look at the type of this, right? Because when you print it out, you notice that the format is slightly different. So we can actually see, okay, it's actually Pandas series, which is a different structure, right, than Pandas data frame. So when you want to convert it to a Pandas data frame, typically you can just do reset index. This will pretty much do the work for you. So now if we look at the type of this, it is going to be a data frame, right? It looks like a data frame when you print it as well. So you can say, okay, so if I do this, I can, convert this into a data frame. So you can see zip code and then the estimated value, the median estimated value. So what if I want to then call this, say, df2, df2, right? And then I want to merge this df2 with my original df, right? So merge means you are combining or joining these two tables or these two data frames, right? So I'm sure some of you will know SQL, but if you don't, then it's pretty much think of it as like joining the two tables or two data frames based on a common column. And then that way you can append more columns, you can get more columns or the superset of columns, right? So what if I want to append, right? So now with this one, so you can actually look at df2. So df2 has like zip code estimated value. What if I want to use zip code to append this estimated value into my original df? My original df, remember, looks like something like this, right? This is by house, but this is by zip code. But I can still merge it. I can still combine it or join it. So the syntax here, the function here is really just, it's called merge, right? pd.merge, pd is our pandas, right? And then you can say df2, right? That's this one. We'll just create it. And then on, right? This is a common field that you want to use to join the two, to merge the two, right? So zip code is a join common column. So I'm going to say zip code, right? And then I can actually say how. How is like, I want to do left, right, or if I don't put anything, it's going to be inner. So some of you might know left join in SQL, but if you don't, just think of it as like you want to include everything from your left data frame or left table to be included in your result, right? So I can call this df3, right? So now I'll say df3.head, right? So now you can see one more columns, which is called estimate value y, right? It's called estimate value y just because df2 has the same column, right? The estimate value. And then we had the estimate value originally from our df. That's why it doesn't know what to assign to. So therefore, it's going to give you x and y like this, x and y. X means it's coming from the left data frame and y is coming from the right data frame. But don't worry too much about this. But what we can do here is we can actually do a quick trick and say dot columns, right? We can say, okay, I want to rename the column to like zip code, comma, median value, right? So now if you look at df, it's going to be, df2, it's going to be this median value, right? It's not going to be a estimate value, right? So now we can, if we do the join or the merge, right? Df is the same, and then, right? Remember how to run it is shift return, or you can actually click in here. So now you can see df3 has median value, right? It doesn't have the weird x and y, and the estimated value is estimated value. So yeah, that's pretty much it for, practical examples of data mining. And the last section is really about data set examples. I highly, highly recommend using Kaggle.com. So go to Kaggle.com and sign up for free. And then you can get tons of data sets, or free data sets. So just play with those, and then for an hour or two. And then if you get bored, just go to kernel, right? So Kaggle has data set, and then the kernel tab will tell you all of the work that people or the competitors have submitted for this data set. So you can actually walk through, look at what other people have done for the same data set and really learn from it. So I feel like that's how I learned the best from Kaggle. You can get the data set as well as example code. And then a lot of time the code is the best in the world. So definitely use Kaggle to get your data. And Reddit is, another source. And then sklearn, right? Sklearn, this is one example. I just took it from the source, like from this link. I just copy and paste it in here. It has a few innate data sets like people always use when they start, learning data science. So this is Iris data set. I'm sure you've heard of this before, but it's actually very easy to get. So you will need to conda install sklearn. So sklearn is Python's library, so you have to conda install the same way that we did for other libraries. And then you can import it like this, right? From sklearn, import dataset. So this is where the sklearn datasets is, right? All of the datasets from sklearn can be imported like this. And then you can say datasets.load iris or load other things, right? Movies or other things. And then you can call it iris. And then this is how you can split from like X and Y. So Y is your target and X is your feature matrix. So there are many, examples like this you can just find online. The code is here, but I would say sklearn is another source of good data sets, but doesn't mean that they are the best data set. I would say Kaggle is good. Reddit is good. sklearn, a lot of static data sets, traditional, or I would say like typical data sets that people use when they're trying to learn. And also Google it, right? A lot of time I just Google, data set or image data set, dogs versus cats, anything that you want. Typically, you can find the actual data set online. So Okay, that's pretty much it for, today's session. So just a recap, right? So this is our first session for data mining course. We went over how to cleanse a data set, right? And filter out the noise and looking at missing values, outliers, and then what is a statistic? Like how do you look at the statistics? How do you get to the statistics? How do you do a simple histogram plot? And then the practical example of data mining. How do you slice a data frame? How do you merge them? How do you manipulate, right, by taking the group by of a data frame? And then data set examples. I hope you enjoyed it. And then the next section is really about installation of Anaconda as well as Jupyter Notebook. So let's do that here. So you will need to go to, I embedded the link in my notebook, but you will need to really go in here into Anaconda's website. And then this is where you can download from here. And then you can get either 3.6 or 2.7. I will say either way. I use 2.7, but 3.6 is better, so definitely use that. And then you can actually, if it's Mac, then you'll get the Mac. And then if you use Windows, then go to Windows and download. This is very easy to download. So Anaconda is pretty much, think of as a library manager that, once you get all these libraries in Python, right? Anaconda is going to allow you to install a new library very easily, seamlessly, and also manage them, maintain them, right? And then once you get this, go here, right? I embedded the link in my video, in my notebook as well, but go to just the main page of Jupyter, jupyter.org and /install. And then you can see, you can pimp install it. Pimp is another way of like installing all these libraries, but the easiest way is really just what we did before, conda install, right? Conda install, and then you need to type in Jupyter, right? That's it. So, I hope, if you have any questions, I'm sure we can talk about it later, but this I think it's very easy to install. And then how do you launch this Jupyter Notebook, right? I'm sure like once you install everything, you can just go to the terminal again. So I have it open here, but yeah, you can just open another one, just call it IPython Notebook or Jupyter Notebook, either way, right? I would just do IPython Notebook. So this will launch, will kickstart a new session of Jupyter, and then it is going to open up a new page in your browser, like here, right? And you see it's gonna open this local host, and then you can start working on it. So say I click on what I had before was so this is a folder and another folder. You can actually create a new notebook like this, right? Go to here, new, and Python 2 or Python 3, and this is how you can start a notebook. And I already have one here. You can see the file extension is IPYNB. It's in here, and then you can see this is how I was having my notebook, right? You can see a bunch of things in here. So that's pretty much it. Thank you so much, and then I look forward to the next section. Thank you.